Have you ever stared up at the sky and wondered why it's blue, or why sunsets blaze with reds and oranges? These daily sky shows are so familiar that we rarely question what's really happening above us. The answer isn't magic, it's physics, a story of sunlight's journey through our atmosphere. Sunlight travels 150 million kilometers to reach us, only to be transformed in its final moments by the air we breathe. The colors we see are clues, messages from the cosmos, decoded by our eyes and brain. That blue sky? It's the result of tiny molecules vibrating with a specific wavelength of light. The crimson sunset? That's light filtered and scattered on a longer, tougher journey. Let's follow a single beam of sunlight as it enters Earth's atmosphere and see how it paints our world with color. By the end, you'll never look at the sky the same way again. Sunlight looks white, but it's actually a blend of all visible colors, a hidden rainbow. Imagine sunlight as a crowd of runners, each color a different stride, all moving at light speed. Each color has a unique wavelength. Red is long and gentle, blue and violet are short and energetic. A prism reveals this secret, splitting sunlight into its spectrum. Red, orange, yellow, green, blue, indigo, violet. Nature's prism is the raindrop, creating rainbows after storms. These wavelengths matter. They determine how each color interacts with our atmosphere. As sunlight approaches Earth, it's a full spectrum of energy, ready to be sorted by the air. The atmosphere acts as a giant, chaotic decoder, scattering and filtering the light. What happens next is the key to the sky's color. Let's see what unfolds when sunlight collides with the air. The real magic begins here. As sunlight hits Earth's atmosphere, a sea of nitrogen and oxygen molecules, something remarkable happens: Rayleigh scattering. These tiny molecules absorb and re-emit light, but not all colors are treated equally. Shorter wavelengths, blue and violet, are scattered much more than longer red and orange waves. Picture rolling marbles, blue light, and a beach ball, red light. Through a dense forest, marbles bounce everywhere. The beach ball rolls straight through. Blue light ricochets in all directions, filling the sky with its color. When you look up, you're seeing scattered blue light, not direct sunlight. Blue dominates because it's scattered about 16 times more than red. The sky glows with this indirect, beautiful blue sunlight's energy, diffused by the air. It's a daily masterpiece, painted by the dance of light and molecules. This is why the sky is blue, not just above, but all around us. The atmosphere becomes a glowing canvas, but why not violet? That's the next mystery. If violet light is scattered even more than blue, why isn't the sky violet? First, the sun emits less violet light than blue, so there's simply more blue to scatter. Second, our atmosphere absorbs some violet before it reaches us. Most importantly, our eyes aren't very sensitive to violet. We have 3 types of cone cells for color vision, but the blue cones respond much more to blue than to violet. Our brains blend the signals, and the result is a vivid blue sky. So the sky's color is a cosmic compromise. The sun's output, atmospheric filtering, and our own biology. The sky is physically violet blue, but we see blue. It's a collaboration between physics and evolution. The universe paints, and our eyes interpret. As the sun sets, the sky shifts from blue to fiery reds and oranges. The reason? Sunlight's path through the atmosphere gets much longer at sunset. Blue and violet light are scattered away before reaching your eyes, leaving only the resilient reds and oranges. The sun appears redder, and these colors illuminate clouds and haze, creating breathtaking sunsets. The exact hues depend on what's in the air. Dust, clouds, or pollution can intensify the show. Sunsets are the sky's grand finale, a testament to the filtering power of our atmosphere. It's the same sunlight, just taking a longer, more colorful route. Every sunset is a physics experiment in real time. The sky's color isn't just about air molecules. Larger particles like dust, salt, and pollution play a role too. These bigger particles cause Rayleigh scattering, which affects all colors equally, washing out the blue and making the sky look pale or white. On hazy days, pollution and water vapor scatter light forward, mixing colors and dulling the sky. Volcanic eruptions can fill the air with ash, creating vivid red and purple sunsets for months. Even famous art, like Munch's The Scream, may have been inspired by such dramatic skies. Clouds made of water droplets scatter all colors equally, appearing white or gray depending on thickness and sunlight. At sunrise or sunset, clouds become brilliant canvases, reflecting the filtered reds and oranges. The sky's palette is shaped by everything in the air, from natural dust to human pollution. Every day, the atmosphere repaints the sky. It's a living, breathing work of art. The sky's colors aren't just beautiful, they're practical too. Old sayings like, red sky at night, sailor's delight, red sky in morning, sailor's warning are rooted in real atmospheric science. A red sunset means clear, dry air is coming. A red sunrise can signal an approaching storm. Observing sky color is a way to read the weather, a tradition as old as humanity. These principles aren't unique to Earth. On Mars, dusk gives the sky a butterscotch hue and blue sunsets. Understanding the science behind sky colors deepens their beauty. Every glance upward connects quantum physics to planetary scale. The next time you admire the sky, remember the journey of light and the physics at play. The universe is putting on a show just for us. And now you know how the magic works. Don't forget to like, share, and subscribe for more videos about our wild and wonderful universe.